This question about remainder theorem is a little bit straightforward. It's because they give you the original function directly with some unknown. So we are just going to apply this case when fx divided by x minus 2, the remainder is negative 5. And by the remainder theorem, there is a method for us to get the remainder directly by using the original function. The remainder theorem tell you that the remainder is equal to, we substitute a suitable value of x to the original function, then it will give us the remainder directly. So this process is by remainder theorem. We know that is f something, but that something, the criteria is to make the divisor become 0. So when the divisor x minus 2 equal to 0, the suitable x is 2. This sentence just simply means that f2 is equal to negative 5. Then we have one equation. Afterward, we have another equation. When fx divided by x minus 3, it is divisible, that means no remainder. Which means that by remainder theorem, f we put a suitable x, which is 3, so that the divisor becomes 0. So f3 is equal to 0. We have two equations. We just evaluate these two independently. Finally, we combine them. Then we can get two unknown. So left hand side, f2, that means we replace fx by 2. It's make our calculation much easier because this is 0. 0 squared times anything is just disappeared despite what is the value of h. So k alone is equal to negative 5. It's because the whole term becomes 0. After that, the another equation. This time replace x by 3. Before we replace it by 3, x minus 2 we can't combine it, but 3 minus 2 is a simple number, 1 square here. So 3 plus h, and also k, we already know that k is negative 5, so we can update the information, negative 5 here. So h equal to 2. We already fulfilled the first requirement here. Then we look at part B. Someone say that all the roots of the equations are integers. So our focus should start from this equation. We are considering fx equal to 0. So part B, we are solving fx equal to 0. What we know about fx, we know the full function already because we get h and k, so we just update the information. Fx is x minus 2 bracket square. X plus h is 2 also, so this is plus 2. And then plus k, that means minus 5 equal to 0. We are going to solve this equation. And then because this is x power of 2 times x power of 1, so it is a cubic polynomial, x power of 3. And then we predicted that there will be 3 roots. But is that all the roots are real or not real or something else? Then we are going to solve it. So the only method to solve it is to factorize it, write something times something equal to 0. Then we can say something equal to 0 or another something equal to 0. Continue to solve it. So the first step is to expand it. We don't know what we can do next, right? So we just simply expand it. Handle the square first. And then handle x times this item, positive 2 times this item. I remove the second bracket. So every term, 2 terms here, we have to times the multiplier outside. So every term x, we have to times x squared minus 4x plus 4. Plus 2, we also need to times the same thing. And then don't forget at the back we still have minus 5. So the first row, we can just focus on every term times x. The second row, every terms times 2. Then it's easy for us to find some like terms to combine them. At least we make it look like the questions that we handled before, and then we are now going to factorize it. We need to think carefully. Is there any hints? Do we know any of the factor here? We know that fx is divisible by x minus 3. So we know we can write in form of x minus 3 times something. How to find out the rest is just simply by division. What time this give you this, then you just simply use this one, divide by x minus 3. So we just use a long division method. And then every time we just focus in the first term, x power 3 divided by x. So it's just simply give x squared. That's why our first quotient is x squared. Afterward, we are going to use x squared times this one to calculate which part we already include. So x power 2 times x minus 3. We get x power 3 minus 3x squared. We put this product here. X power 3 minus 3x squared. Finally, of this cycle, we are going to subtract them. So we have to think negative 2x squared minus what below negative 3x squared. That's why we have positive 1x squared. And then we finish one cycle already. Another cycle, we just continue. We use this divided by this. It gives us 1x. And then negative 1 divided by x, we get negative 1 here. And we have no remainder. It's consistent with our conclusion that x minus 3 is a factor of fx. So now we know that the quotient is x squared plus x minus 1. Again, since something times something gives you 0, which means that either this factor is 0 or this factor is 0. Then we downgrade the equations to a linear equation and also a quadratic equation, which is much easier to handle. For this part, we just use what we have learned in primary school. X is equal to 3. This is one of the roots and it is integer. Now the key point is here. This is quadratic. So ax squared plus bx plus c. We use our formula 1. We can get the value of the roots. So we just simply, if you remember the formula, it is negative 1 and then positive negative b squared minus 4ac. And then divided by 2a. It's definitely not integer. Or if you use calculator, it gives you x equal to 0.618 or x is equal to negative 1.618. So both of them are not integer. And then since these are not integer, and this is not integer, also this one, integer means whole number. That's why we do not agree the claim.